So what if we could make our data, well, smarter? I'm not just talking about storing information. I mean, what if we could teach our computers to actually understand it? Today, we're going to dive into a really powerful tool that promises to do exactly that.
Okay, so before we can get to the solution, we really have to get a handle on the problem. And it's a problem that's kind of hiding in plain sight in pretty much every computer system we use.
It sounds a little harsh, doesn't it? But think about it for a second. We have these absolute mountains of information stored on computers. But what does the computer really know about any of it? Here's a way to think about it. A computer can store the word salmon, no problem. But it has absolutely no idea that salmon is a type of fish, or that it's an ingredient, or that you might find it in sushi. To the machine, it's just a string of letters with zero meaning. Our job is to give it that meaning.
So how do we bridge that gap? How do we take data from just being stored information to being understood knowledge? Well, this is where a concept called an ontology comes into play.
Yeah, I know that is a mouthful, but don't worry about the jargon. Just think of an ontology as a rule book for a specific topic. It's our way of formally defining all the concepts, all the categories, and the relationships between things so that a computer can finally understand the context. And to make this really concrete, we're going to build a tiny little rule book, an ontology, for a sushi restaurant. It's a simple and, hey, delicious way to see how all this stuff actually works in practice.
Building our rulebook is basically a three-step process. First, we need to create our main buckets for sorting things. Then, we need to draw the lines that connect those buckets. And finally, we get to fill those buckets with actual, real-world stuff. All right, first up, classes. Just think of these as the big buckets for sorting everything. So for our restaurant, our two main buckets are going to be sushi and ingredient. We're officially telling the computer, hey, these two categories exist in our little world.
But just having a couple of buckets isn't enough. We need to connect them. And that's where properties come in. We can create a property, let's call it hasIngredient, that creates a really meaningful link between our sushi bucket and our ingredient bucket. All of a sudden, the computer doesn't just see two separate things. It gets their relationship.
And finally, we add the individuals. These are the specific, real-world examples that belong in our classes. So, salmon sushi is an individual that belongs to the sushi class, and salmon is an individual in the ingredient class. And just like that, our rulebook is starting to look like a real menu.
Okay, so we understand the what, building one of these rulebooks and ontology. But how do we actually do it? Well, that is where this fantastic piece of software called Protege enters the picture. You can think of Protege as the industry-standard workbench for building these knowledge rulebooks. It's this powerful, open-source tool that came out of Stanford University, and it's trusted by a huge global community. Seriously, when professionals build ontologies, this is the tool they're using.
And what's cool is you have options, depending on what you need. There's Protege Desktop. That's a powerful app you run on your own computer, perfect for those really deep, complex projects. And then there's Web Protege, which lets whole teams collaborate on building these rulebooks together, right inside a web browser. But listen, building the rulebook is really only half the story. The magic, the truly powerful feature of Protege, is its ability to reason, to infer new knowledge that we never explicitly told it.
Let's go back to our sushi example. Imagine we add a couple of new rules to our ontology. We define a subcategory of sushi called nigiri, and we create a rule that says all nigiri must have exactly one ingredient. Then we also state as a fact that our salmon sushi has exactly one ingredient.
Now notice what we didn't do. We never explicitly told the system that salmon sushi is a type of nigiri. We only gave it a set of clues. So, with just those rules, what can the computer figure out all on its own?
And this is the incredible part. By running what's called a reasoner, the system just connects the dots. It sees that salmon sushi has exactly one ingredient, and it knows that anything with exactly one ingredient must be a nigiri. It inferred a new fact we never told it. That is how you make data smart. Okay, look, a smart sushi menu is a fun example, right? But what happens when you apply this very same logic to science, to global business? The same principles that figured out our nigiri are changing the world in some really profound ways. The same principles we just used for sushi are being used right now to map the entire gene ontology, helping scientists understand the incredibly complex relationships between genes and diseases. Huge corporations use it to model their entire business structure, and this is the foundational tech for the semantic web. This vision for a web where information is linked and understood by machines, not just displayed by them. So when you hear someone say Protege is a cornerstone, This is what they mean. It isn't just a piece of software. It's a fundamental tool for encoding human knowledge in a language that machines can finally work with and reason about.
So if this is what's possible today, where does it all lead? What does a future that's built on truly intelligent data actually look like?
I think the key takeaway here is this. Every single one of these rulebooks, every ontology ever built, is like writing a chapter in a new kind of encyclopedia, one that's written for machines. We're slowly but surely shifting away from just storing dumb data and moving towards building a web of intelligent, connected knowledge.
And that leaves us with one final and pretty profound question. If we now have the power to write the rulebooks that define reality for our machines, which rules are the most important ones for us to write first?